we have this situation over here whereby it's looking at the heights of plants planted in Hougang. It's recorded and represented in the cumulative frequency curve below. Okay? We want to find the values of A and B in the group frequency table below. Okay, so how will we be able to determine the values of A and B based on this cumulative frequency graph? Right? Okay, first of all, you need to realize that this is not a cumulative frequency table. Okay, so we need to actually form a cumulative frequency table in order to be able to get this graph understanding. Right? So in this case, if I want to have my group, my cumulative frequency table, okay, heading will be height in cm. Okay, tell you what, just write it on the whiteboard. And then after that, the number of students, which is the frequency in this case. Okay, so based on this table, height of plants, okay, or number of plants. So first one, we will be looking at x less than or equals to 120, that will be 30. Okay, then x less than or equals to 140, that will be 30 plus 80, so 110. X less than or equals to 160, so 110 plus A. Okay, then after that, lastly, we have x less than or equals to 180, that will be 110 plus A plus B. Okay, sorry? More than 100. Why do you need more than 100? Everything here is more than 100. We always saw an upper boundary always. Right? Okay, then after that, according to our cumulative frequency curve, okay, if I were to locate where x is less than or equals to 160 cm, okay, so 160 is over here, we find that the reading that it will give us, right, that would actually be 155. Right? So therefore, it means that 110 plus A will be 155. So therefore, we can find the value of A. And that will be equals to 45. Okay? Then after that, next one, right, x less than or equals to 180. So looking at where 180 is for the height, which is the tail of the curve, okay, we will be able to read that it is going to be 160. So 110 plus 45 plus B will be 160. So B will be equals to 5. Any questions? Yeah. Sorry? Huh? This value is not going to be the reading value. Can also. Okay, this is not, of course, not the only way of doing. Alright, you may not want to actually give your cumulative frequency curve, okay, you can read directly from the graph and then match accordingly to the frequency table, that's also fine. Okay, are we done? Alright, so the homework, okay, textbook exercise 3A, page 74 to 76, question 4, 5, 6, 7, due on Thursday. Okay. Sorry? Okay, we'll move on into median, quartiles, percentiles, range, and third quartile range. Okay, so first we need to understand what is discrete data. Okay, discrete data doesn't mean that they are very secretive. Okay, it just means that they are distinct. Okay, so discrete data refers to a set of data which only takes on distinct values. Okay, so earlier on, going back here, in Sec 2 we have already learned how to find median. You remember what is median? How to find median? Okay, it is the middle data value, right? Okay, and then of course we need to arrange it in ascending order first. Okay, so distinct values for discrete data. Okay, so a data showing the number of phone calls received in a day, okay, can only take out distinct values. So for example, it's going to be integer or whole numbers in this case. Okay, 1, 5 call. Alright, it cannot take out a decimal or fractional value. Okay, so this is what we mean by distinct values. Okay, there's no range around it. Okay, this is unlike. Okay, so this is discrete data. What is considered not discrete data? There will be a situation whereby if I were to take a data of the heights, okay, of the people in this class, and I want to measure up to 1 decimal place. Okay, measure up to 1 decimal place, then there is this whole range that I'm going to have. Right, so it would then be actually a continuous data in this case. Okay, so looking at example 5, right, because we have odd number data over here and it has already been arranged in ascending order. Okay, recalling how we find our middle value, or rather the median. Okay, so since it's odd number, okay, and there is a total of 3, 6, 9, 10, 11 data over here. So total n is equals to 11 data. Total data is 11. Okay, so we will then pick out the number 6 data over here. This will be our median value, right? Okay, so then after that, now we will try to understand, okay, what is considered a quartile. Okay, quartile, as it suggests, it is looking at quarters. Okay, so that means from this data found on the left of the median, we will pick out the center one, okay, which is number 6. Okay, so this is what we call the first quartile. So we denote it as Q, capital letter Q, and then a small number 1 at the bottom right. Okay, likewise, okay, on the right side of the median, okay, the middle value 20, okay, it is going to be my third quartile. So where is my second quartile? My second quartile actually refers to the same thing as the median. Okay, so it is continuously, you just take the middle one. Alright, so the lower quartile value will be 6 and the upper quartile value will be 20. Okay, then after that, to measure the spread of the data itself, okay, there are 2 ways to measure the spread. Okay, that means how it ranges. Right, so range itself, okay, it is defined to be taken as the largest data value maximum minus away the smallest data value, which is also the minimum. Okay. So in this case, that will be 30 minus 2. So the range itself will be 28. Then after interquartile range, that is where we take the upper quartile minus the lower quartile. Okay, upper quartile is Q3, lower quartile is Q1. So therefore we take 20 minus 6. That will be equals to 14. Okay, so what exactly is the interquartile range? Okay, the interquartile range is a measure of spread, okay, of the data, it is a measure of spread that is the middle 50%. Okay, because we're only looking at this part over here. Okay, this is the bottom 25%, second 25%, third 25%, and then the fourth 25%. So interquartile range only considers the upper quartile minus the lower quartile. So we're only looking at the spread of the values in the middle 50%. Okay, looking at the interquartile range is better than looking at the range, because it only looks at the middle 50%, right? And it is not affected by the extreme values, right? So very rarely we will need to do a discussion based on range. Okay, we will usually be using interquartile range to do our discussion. Okay. Let's look at another example on even number of data. So in this case, we have our marks obtained by 8 students in the science quiz. It has also been arranged according to ascending order. So we need not go and do the arrangement. Okay, we want to first find out what is the lower, middle, and then the upper quartile. Okay, so we always identify the middle one first, then after we segment from there. Okay, so the middle will actually be here, right, between 15 and 18. So that is Q2. Okay, so Q2, which is the median, will be 15 plus 18 divided by 2. Okay, this is how we have always been finding our median when we were set 2. Right? So this will give us the value of 16.5. Okay. Just so coincidentally, right, the left side of the median, okay, it is also even number of data. So then the middle will be between 9 and 11. If it were to be odd number of data, okay, for example, if there is 10 data, if I add on another number here, and okay, something like that, right? Then there is actually 5 data set over here. Then the median would then be 9. Okay, so you act accordingly based on the number of data found on the left and the right of the median. Okay, so now since there's even number, so therefore it will be 9 plus 11 divided by 2 for Q1. So that will be 10. Okay, likewise for Q3, that will be 20 plus 22 divided by 2, so that will be 21. Okay, part 2, finding the range, that will be 23 minus 7, 16. Okay, part 3, the interquartile range. That will be equals to taking the third quartile 21 minus away the lower quartile 10. So answer 11. Any questions up to here? Okay, if not, will you turn to your textbook, practice now 3, page 81. Question 1 and 2. Go.